So my last one is actually a space story from me.
Space story from you.
So maybe you can elaborate on some of the things I'm going to say
We'll
here.
see. I don't really know much about space.
I just went to school for 4 years and studied it intensively.
5 years.
Oh, five.
God. Oh, God.
Oh, God.
Good.
My lab classes weren't offered at the right times, right? I had to wait a whole extra semester.
That's what it was.
Those jerks.
Yeah.
All right. So this one comes from sciencenews.org. And the question that they ask in the tweet is, how did we find a dozen new black holes in the Milky Way center? So, and then the quote was also, there could be thousands more, end quote. And so astrophysicist Charles Haley out of Columbia again, Columbia doing a lot of big stuff out here, and his team, et al. He was with a bunch of people.
Yeah.
And they studied stars actually spiraling inward. So they looked at data from stars around where they thought there might be black holes, and they found traces of the stars slightly spiraling inward towards a mass.
Okay.
And this was published in Nature, the journal, on April 4th, so very recent. And so as a star would be orbiting a black hole, because a black hole is just mass, like anything else that things can orbit, as the stars orbit the black holes, they start to spiral in slightly as they approach it and get closer. And as the stars are orbiting in, the black hole, as you know, can rip material off the star into it.
Mm-hmm.
And what the study said was that as the stars were slightly spiraling inward, as the accreted material from the star was being pulled into the black hole, it actually got heated up enough to where it was emitting X-rays. So they had evidence of the material that was coming off the star that would be going into the black hole that you can't see it anymore. It ended up being heated up by the process of being pulled off, and they could track it. And by tracking the way the stars were moving and the X-rays from the accreted material, they ended up reporting that they found 12 black holes that were near the center of the galaxy, of the Milky Way Galaxy.
Okay.
So, theoretical predictions predict up to from anywhere between 25,000 to nearly 1 million black holes near the center of a galaxy.
Wow.
That's what I was reading.
That's a lot.
So let's sort of break this down a little bit.
Yeah.
In the inner Milky Way, what we're talking about, the middle, is actually 3.26 light years across.
Okay.
So it's a big section, but it's in the middle of the whole Milky Way galaxy.
Mm-hmm.
And you can confirm this. I'm not sure if I'm completely right, but I'm pretty sure we know as a fact that there's a supermassive black hole at the middle of the Milky Way.
Yes.
That's confirmed. A huge one.
Confirmed, yeah.
Just a gigantic black hole.
Sagittarius A.
Just a huge one.
Mm-hmm.
So we know that that one's there, but according to the theoretical models, there should also be upwards of approaching 1 million other black holes that aren't nearly as massive as the supermassive black hole, but concentrated somewhere near the center of our galaxy.
Okay.
So we're trying to look for these black holes in order to better understand our theories of dark energy, dark matter, and matter in general. Because we know there were supermassive black holes there, but are there really this many black holes? So this study only found 12. And another quote that I want to bring up was, they said finding 12 was hard. They said took a long time of really looking at the data and seeing these X-rays being emitted and stuff. So does that sort of dishearten you to think that we can't find this many black holes? Or maybe it's a slightly different theory that we need?
Now, here's the thing.
Okay. I might be spewing slight knowledge.
No.
Okay.
This is, yeah. When you're looking at the center of the galaxy, and you're looking for what I'm assuming to be stellar black holes, right?
Yeah.
Black holes the size of
About a star.
ultra-massive stars, right? But you're looking for them in these indirect means, right?
You're not just looking at them.
Right. We're not exactly looking for a black spot in what otherwise would be
a bright light.
right, a massive amount of light emitted at the center of the galaxy. You're looking for a spike in X-rays to tell you that what you're saying is the accreted mass is
Going towards a black hole.
right.
Yeah.
Now, I'm not doubting at all that the findings of this team are accurate, but what if what we're looking at is just the turbulence of some sort of matter in the center of the galaxy that is whipping around at speeds where the reaction causes there to be an X-ray emission?
That's not exactly from an accretion process.
Right. So, I think that this is probably...
So that's a good point. So I wanted to say this, but I'll say it right now
Yeah,
because
sure.
right after what you said, the team admitted that not all of them can be 100% confirmed as black holes.
Mm-hmm.
That a few of them might be super fast spinning millisecond pulsars
Okay.
that they dubbed being black holes based on the data.
Yeah. I'm definitely not doubting that there is some sort of star that's definitely massive that's causing this
to happen.
thing. Yeah, that's causing these X-rays to be, detectable, basically. Are they all individual stellar black holes? Maybe not.
Yeah.
It's going to be tough for us to say when this year, Tom, we're hoping to be able to image for the first time the giant galactic black hole, supermassive black hole
That's
at the center of our galaxy,
insanely large,
where
yeah.
we think all of these other little stellar black holes might be falling into to create this one big massive thing at the center of our galaxy. We're saying, okay, now there's a swarm of these little stellar black holes that are kind of whipping around in the center of the galaxy and causing these X-ray bursts to be emitted that we can detect. I don't doubt it for a second, but I think that this type of research can definitely use some cross-verification before we say for certain that, hey, there's X amount of black holes in the center of our galaxy. But I do appreciate the research for sure. I think that this is definitely a unique way of looking at the center of our galaxy and trying to draw some sort of conclusion from what's going on out there. Yeah.
Cool. So looking at the chat, just taking a few steps back, Blue Hawk said hilariously, imagine the sewage at a music festival. Exactly.
Yeah.
Okay.
I think people just shit in the woods at festivals. So.
And then moving on, Amber says, do you think we'll find more black holes? So, like you're saying, yeah.
I think undoubtedly so. I think as our capabilities get stronger, and I think as our telescopes become more,
we'll just be finding more and more and learning more and more about them.
More well-defined. I think that the Event Horizon Telescope that is supposedly going to produce an image of the Sagittarius A black hole at the center of the Milky Way Galaxy.
I'd be very interested to see what that is.
Yeah, I think more iterations of that can hopefully help, target more individual black holes that we might be able to find at the center of the galaxy. That's cool. The goal.
And
that's
then
the dream.
Another thing that I read, there was another theory coming out from Columbia that black holes can be actually born around a disk around the supermassive black hole, and that we might have to take a step back on what we're saying are specific numbers of black holes that just exist and how they might be coming in and out of existence around this insanely massive black hole, and that our theory might not be as sound as we even think it is in the first place.
Wow.
So lots of room to improve on our black hole understanding.
Yeah, for sure.
Yeah.
Very cool. Awesome. Thanks for sharing.
Yes, sir.